Hi, it's Mohammed Ragab, a PhD candidate at the Data Systems Group, University of Tartu. In this video, I'm presenting our accepted poster in the ISWC'20 conference with the title Comparing Schema Advancements for RDF Querying Using Spark SQL. This paper is authored by me, Riccardo Tomazzini, and Sharif Zakr. First of all, currently we witness huge RDF datasets from the popularity of knowledge graphs and RDF datasets on the web. The straightforward approach is to process RDF datasets using RDF stores such as RDF XXX or GStore, taking benefit of the expressiveness of the SPARQL query language. However, these RDF systems are centralized and don't scale well to the large volume nor to the complex queries on web scale RDF data. To overcome this problem, the Semantic Web community starts to investigate big data processing frameworks such as Hadoop and Spark, harnessing their scalability and performance enhancements. However, the fact that these big data frameworks such as Spark were not originally tailored for RDF processing, they excel for relational data processing, thus several solutions have proposed to utilize their query engines for processing large RDF graphs. Now the question is, can we run SPARQL on top of Spark? Actually, do you think that's a graph you are querying anymore? It's not graph anymore. So we need relational RDF relational schemata to represent the RDF graphs. Intuitively, the choice for relational schema significantly impacts the performance of query processing. For instance, the baseline RDF relational schemata, such as a single statement table, which prescribes to store RDF tables using a ternary table of subjects, predicates, and objects. Many attributes, many alternatives to the single statement table exist. The vertically partitioned table, or VT, proposed to use binary relations, subject and object for each unique predicate in the datasets. And the property tables schema, which suggests n-ary relations to represent RDF tables, grouping them with the same subject. In this paper, we aim at validating two further improvements of relational schemata proposed for Apache Spark. First of all, the wide property tables, WPT, that extends the property tables schema considering the whole dataset in a wide single table with a row for each subject and their respective flattened predicates. Second, the extended vertical partitioned tables, XVB, that extends the VB schema with pre-computed semi-join table to reduce the input table sizes and data shuffling. In particular, in this paper, we investigate the improvement. We performed an extensive comparative evaluation of XVB and WBT versus VB and BT respectively using Spark SQL. To check the generalizability, we tested how these two schemata advancements behave against their baseline when introducing different RDF partitioning techniques and the HDFS storage formats. Partitioning techniques impact the query execution as they change the data locality. In particular, we use the following partitioning techniques. First, we use the horizontal partitioning, which divides data into horizontal chunks over n number of machines in the cluster. On the other side, we used the subject and predicate partitioning that distribute triples across various partitions according to the hash value computed for the subject and predicate respectively. Notably, we tested the baseline the literature baseline vanilla HDFS partitioning that applies random horizontal data partitioning of the data blocks in HDFS. On the other side, the storage data formats are considered by the Spark optimizer and that impact the physical query plans. Therefore, we use two row-oriented data formats, CSV and Avro, and two columnar file formats, ORC and Parquet. Similarly, as the baseline storage format, we choose Parquet from the literature as a baseline format. Now we move to our results. Our findings we start with the WBT versus PT comparisons. According to this table that shows the number of joins in WBT versus PT for the SP2 bench queries, we expect that WBT outperforms the PT, especially with the star-shaped SPARQL queries that can be answered without any join operations using WBT. We also expect that Parquet handles efficiently the sparsity comes with WBT, thus outperforming other storage file formats in Spark. The second table here shows the overall benchmark results of WBT versus PT across all 5 formats horizontally and all partitioning techniques vertically. The table values specify the number of queries in which WBT outperforms PT. The experiment's results confirm that WBT outperforms the baseline PT schema in all queries, 9 out of 9, using the baseline configuration Parquet and the non-partitioning or HDFS partitioning. However, this was not confirmed with a complex solution space of different partitioning techniques and various storage formats. Thus, we can see that from the second table that the number of queries that WBT is better than PT reduced moving to other partitioning techniques and storage format. Actually, the third table also shows in percentages the effect of data partitioning on the left and the storage formats on the right. For instance, table 3 shows that WBT outperforms PT with only 58% of the experiments when baseline partitioning or HDFS partitioning is used, but across different storage formats, while it outperforms only with around 78 of the experiments using Parquet alongside with different partitioning techniques. This clearly shows the trade-offs among partitioning techniques, file formats, relational schemata in the WBT versus PT experiments. Now we move to the XVB versus VB comparisons. The performance difference between these two relations schemata basically depend on the percentage of semi-join reductions that XVB might introduce over VB, of the input table sizes that participate in the query joins, as shown in the first table over here. For these SP2 bench queries of 100 million datasets, we compare XVB versus VB in the similar way that we do in WBT versus BT. We can observe that for queries, query 9, query 9, query 10, and query 11, that they don't gain any input table reductions from the XVB semi-joins. XVB doesn't outperform VB schema over even for the baseline state-of-the-art configuration HDFS and Parquet. So it's only 7 out of 10 queries outperformed in XVB. The next table shows how far the data partitioning and data formats impacts the results of XVB in comparison to VB schema performance. The table shows that partitioning significantly degrades the performance of XVB, which degrades from 67% adopting the HDFS partitioning to 35 and 55 percentages adopting horizontal partitioning and predicate partitioning respectively. On the other side, the small number of projections in SP2 bench queries suggests that columnar file formats can fit such query workloads better than the row-oriented ones, as shown in this table here. As a conclusion, we investigated the reproducibility of RDF relational schemata optimization within distributed Spark SQL while introducing complex experimental solution space of data partitioning and storage formats. The optimized relational schemata can be affected easily with new experimental factors such as data partitioning and storage formats. And that's from our side here. And this is a link of GitHub repository. You can check it. And thank you very much.